So in trying to come up with the topic for this week's video, I was stuck because I was, had a pretty busy week. So I thought to myself, well, what I'll do instead is record a chunk of the work I was doing and just narrate over top of it because I think there's some value here. We're going to talk about how to model an asset that works at different resolutions, or at least one approach to it. My next mini pack that I'm doing requires this. It's going to have some meshes that are good for cinematics, some meshes that are good for in-game, and some meshes that are good for UI or HUD elements or inventory or whatever. So we're going to walk through the low poly through material pass on those three situations, and hopefully you'll get something out of this. Let's dive in. Oh, and I've got the hat on because it's freezing cold here in Raleigh, and I haven't shaved in several days, so you're just going to have to love me as I am. Okay, so to kick this off, the first thing we're going to do is I copy off the high poly mesh, the whole folder structure that I have it contained in, and I make a low poly folder structure. That allows me to use the high poly meshes as a jumping off point. That's really all it is. I give the low poly meshes a distinctive texture, or their own material I should say, with a distinct color. That way I can tell it apart from the high poly easily, and so when I toggle it back and forth I can see what's penetrating with what and that kind of thing. Now the method that I typically use for stuff like this that has a lot of curves and weird shapes is I will take it down to a subdivision level of 1 and then I'll freeze the geometry. And then come in afterwards and pick every second edge loop and delete it. That allows me to maintain the curvature pretty well on the low poly, and saves me from having to fiddle around with trying to retopo it or whatever, which tends to be pretty slow. Now you're probably noticing this is kind of high poly-ish, but bear in mind this is the cinematic mesh. This is not going to be the in-game thing, so this can afford to be a little higher poly, and it will be. So I just keep grabbing high poly pieces and splicing them together with the other piece that I started with, and we just progress down the key like that. Oh, and for reference, we're only going to do this one key here because this process can be a little tedious to watch for an entire mesh, but you get the idea. So again, we're going to freeze this part. We're going to freeze these parts and tear out edge loops. And then once the edge loops are torn out and it all lines up, then we'll delete extra polygons. We'll merge polygons together, or sorry, merge vertices together, and that kind of thing. And come up with a cohesive manifold mesh in the end. But it's really just a whole lot of that going on. So let's just watch this, and if something interesting happens, I'll pop back in. Now this was a problem that I ran into. I got a little overzealous with with clipping out the geometry because the low's not really matching up with the high that well. So I needed to add an edge loop back in. I needed to push those loops back out. And you don't have to exactly match the high poly mesh, but you do have to be relatively close, to have any expectation of a clean bake. So that's what you're seeing here, is me trying to fiddle around and correct that mistake. You'll see me do this from time to time as well. I will take half the mesh away and just work on the front half of the mesh or whatever, and then when it's done, I will mirror it back over. Now, in the case of this, it works out pretty good because I want to have a mirrored bake anyway. And you can tell that I messed up here, and I had to go back and make sure I was deleting the right stuff. It's funny when you watch somebody working in real time. They end up with a lot of like stupid mistakes and stuff you wouldn't have happening in a polished kind of tutorial. But there is a lot of value in watching somebody screw up because you get to see, well, the reality is really that you know everybody models basically the same way, and uh, we all make mistakes, and it's normal. It's just refreshing sometimes to see. So I think I'm just about done screwing up on this top part, and I think we can move down here in a second to the lower part. Now what I'm looking at here is I'm trying to line this up because I want to mirror this across, but typically mirroring works best when the mirror line is flat. So I'm going to extrude that edge out and then snap the position right to 0x. So when I mirror that over, it's going to be flat, and that'll help it to go with no seam, which will be good. That's kind of the goal. You want the cleanest bake possible. And what I said earlier about your low poly needs to be close but not exact. You can kind of see that happening here when I turn it back on. There's some parts that are poking through. There's some parts that are not poking through. And as long as it's all relatively within the ballpark, that's fine. You can see another mistake here. I deleted one polygon too many, and I kind of had a brain spasm trying to figure out how to fix that. But then I decided, well, once I splice on the bottom part, that'll just naturally fix itself because I could just do a quick bridge. So I opted just to keep trucking. Yeah, so you can see once we punt all this stuff out, yeah, that's enough. Okay, so now we have half there. And I'm just kind of verifying that stuff is mirrored because I had a horrible thought in my head. I thought, what if there's like an uneven number of edges here or something? But I seem to have made out okay. Okay, so now we're going to delete the interior part of that upper mesh, and then I'll throw a bridge on it. Yeah, and then we'll be back in business. There. Screw up resolved. So again, we see the same sort of problems there where the curvature wasn't quite matching up, so I scooted everything together. Now this part here, I for some reason fooled around a little bit too long on this. I was trying to get it so the bottom would match up, but I wanted it all to merge to a point, in the center there, and my brain eventually decided that what I would do is join join the outermost vertices together, then collapse the others into it. But it's funny, sometimes it just takes your brain a little bit longer than you would like to come to these conclusions. There we go. Yeah, I think what I'm doing here is trying to decide how much geo I actually need, but I was kind of getting caught up in in thinking about it as a game res mesh, and I probably cut that a little too low, to be honest, for a mesh that's going to be used in cinematics. But it's fine for demonstration purposes. Maybe I'll change that before the pack is finalized. Maybe I won't. You know, it all depends. So once again, we're freezing and deleting edge loops. This one gets a little trickier because there were a couple of gotchas that I hadn't thought of ahead of time, but this is just basically going through, and any edge loop that doesn't affect the silhouette of the low poly mesh needs to go. So that's really all I'm doing here. It's just killing everything that doesn't form the silhouette shape. And in the end, you end up with a pretty low poly cage down here, and that's fine because we're using the rounded edge shader. So that inner penetration you see on the left side, that'll all go away in the bake, and you'll see that that ends up looking nice. You see there, that was a bit of a gotcha because I couldn't. There was a rogue vertice there that I just took care of, and that loop on top kind of comes around in a funny way. It's just stuff you have to notice and fix, and then you'll be able to carry on successfully. Right, so that looks pretty good. So I'll dupe that, flip it, and move it up to the top to be the top part of the key. And then I think we're just about ready to put the UVs on this thing. Okay, so time to put some UVs on this. Now these are not going to be all that complicated. So first we punt, whatever got put there by default. And I tried a straight planar map, but it didn't work out. So we're going to do an atlas. And what atlas does is it breaks the UV islands automatically, after a certain amount of change. I think it's, well, I don't know what it is actually, but it works out pretty good at the default level. Now on some of these islands, I'm using the rectangle command, which straightens everything out to a rectangular shape, which is really nice for stuff that doesn't relax straight. But this is pretty straightforward. Now we've talked about this in prior videos. I tend to break my UV islands regardless of how small they are. When the smoothing changes on that low poly, I break the UV islands, and I don't care if it gives me extra verts or not. I just do it. I find that spending a few vertices these days is a smaller crime than having bake errors on the mesh. It's just kind of a trade-off. You pick which way you want to go, right? So this is just, the other one got atlas the same way. Now, marching up the key, you still have the same sorts of rules. You need to stop when the smoothing breaks and make that an island. So we'll stop right there. Grab that and walk up to there. Now there's a change right there. So we'll do a cylindrical. Well, I tried to do a cylindrical wrap, but then I remembered that this is not cylindrical. It's actually flat. So I switch over to planar mapping and hitting the rectangular command to make sure they're tight rectangles. There's some stuff like that I probably should have broken off, but it's so small that you're not going to see the bake error. It's it's really all circumstantial. Whether you want to eat that or not. I chose not to in that case. I am choosing to here. Now when I got up here, I initially thought I would do a couple of cylindrical unwraps, but then I started looking at it and I thought, well, that might be better off as an unwrap actually. So I just defined, and I forgot that little piece right there. So I have to go back and recover that. More mistakes in real time. Fun stuff. All right. Oops. Okay. So getting back to this chunk. So I define my seam, and when I decide what the seams actually are, I then fire off the unwrap. Yeah. So there's two islands because there is a smoothing break leading into the interior island. Now what I'm ending up with here is I'm seeing that because of the length of that one island, it's screwing up the pack. The pack can't, is getting jammed up on this. So I thought, well, why don't I unwrap that differently? We'll do it in two evenly spaced islands instead. And now when I pack, you can see we get a much fuller pack because that one island's not dominating so far in that one dimension. You know what I mean? Now that looks a little janky to me. Little tiny island or little tiny polygons like that, they don't tend to do real well during the bake and on the normal maps. So I'm scooting them up and I scale them out a bit to give them more of a presence on the mesh and on the UV map. So now I think I relaxed that island and repack. Yeah, it's just the nitpicky stuff you end up doing to a UV map. So yeah, I think we're about good to go there, and we're going to bake the normals. So this is not a tutorial on how to bake normal maps. We're just going to kind of bang through this. So real quick, I will add a new image to the low poly material. Make it 2K and say OK. Then, let's see, what do I do here? I'm turning it off here because it has some, some residual splooge on it, and I didn't want to deal with it visually. So what I'm doing in this case is I'm going to mirror the mesh and then move the mirror pieces to the right, one UV unit. And I tried to do it there, but they're all welded. So I'm going to have to break them off and then move it over. It's, just the dance I have to do. But now this is one way of mirroring a mesh successfully. Then you update the smoothing on the mesh, and so that all looks good again. Now I can bake cleanly because those mirrored islands are pushed off to the side and won't interfere with the main bake. There's already a cage on here that I put on previously, so it knows what to do. So all I have to do is say bake, right down to it, and off it goes and does it. There's other ways to bake mirrored meshes. For example, you can, well, depending on the mesh, you can just bake half the mesh, and then when you're all done, just mirror it over and splice the low poly together. Now that only works when the mirrored edges are flat, because then you don't have any kind of a curvature for the normal map to account for. And that's important because that's where you end up with seams on your normal line. But in this case, the way I've done it will result in no seams or weirdness. So there we have a successful normal map. I see the rounded edge shader is kicked in nicely, is helping with those transitions. The mirroring looks good and clean. Actually, it doesn't. There's little sploogey errors on some of these edges. And I realize that's because I forgot to set up my smoothing. So using the Vertex Normal toolkit was to smooth the whole mesh, then hit that top right button that breaks the smoothing on all the UV islands. I've talked about that in the past. So having fixed that, now we're going to bake again, and this time that splooge should be gone. But yeah, getting back to mirroring, I mean, if your mesh just shares pieces across the mesh, you don't need to have those there for the bake. And like I said, if your mirror line is flat, you don't have to have it there beforehand. But if you have any kind of a curvature, like I have going around the center column of this key, you need to have the whole low poly mesh there, because when it computes the vertex normals, that's going to need to take that curvature into account. And with half the mesh there, it can't. and that's how you end up with seams. So you can see all that splooge is gone now, and we're happy. So I'm going to pull this into Substance Painter, and we're going to give it a material and see what it looks like. So I've gone ahead and I've pulled the mesh into Substance Painter already, and we're going to import the normal map and assign it to the mesh. This is how I do, well, I do a lot of stuff this way, and this may make some people cringe, but it's working well enough for me that I don't really care that much. So what I do is I bring in the bake normal map from Modo. You can see that's on the mesh now, and the mesh is looking nice. From here, we need to bake the other maps that go on this mesh. Curvature and AO and thickness and all that kind of stuff. So the way Substance Painter works is that as long as you have a normal map and a low poly mesh, you can bake the other maps from those two items. Sure, there's some stuff that gets approximated, that's true, but it's close enough that you get a good result. So I really haven't been too bothered about it, to be honest. Oh, and the bake is super fast, which is also a huge advantage. Okay, so we're done. Now what you see me doing now is this is typically what I will do with assets. I'll put the curvature map as an overlay at the top of the stack, and give it like a 50% strength, and then I will throw a blur on it to kind of cover up any splooge that it might have, and it just gives the edges and stuff just a little bit of pop. So if you when you have the final material on, the effect is very subtle, but you do notice it. Okay, so now what I'll do is I'll pick some smart material. Now, I've got a bunch here that I made for We Happy Few that I might as well just use in this case. So that's just a straight up metal. That's me toggling the overlay. You can see, it does make a difference. Now, since that looks pretty good, I'll just hide it and I'll try another material just to see how I feel about it. And I drop that into the folder by mistake, drag that out. That I like a lot better. Yeah, actually that's very nice. That's got some nice patina on it, some nice dirt down in the crevices, and yeah, I like the way that looks. So we're probably, well, not probably, we're going to roll with that as our actual material. So after this, we're going to roll back into Modo and talk a little bit about making the game res mesh. Now this is the other stage of what I was talking about, the cinematic mesh. Now we're going to make the game res mesh. So in this case, it's just going to be a simple matter of knocking out edge loops. But you can see here that I had the normal map showing on the meshes. So as I'm knocking out loops, I can keep an eye on things and make sure that it's not, screwing anything up by deleting certain loops. Here I'm selecting every second edge loop and killing it, which gives us a jankier outline, but in terms of the game res mesh, it doesn't matter. And I just continue on doing that, deleting every second edge loop. Now you'll see here there's another mistake coming up. So I've deleted all of those, and I want to get rid of that one, which is fine. But then when I turn, you can see there's a bunch of splooge on the side. And that's because I deleted the edge loop that was running on the mirror line, which is going to cause all kinds of jankiness because it's going to be merging vertices across islands and all that. So scooting my edges over one makes that all happy again, and it looks nice. So yeah. I wanted to kill that middle edge loop down there, but I can't because that's the mirror line again. So you can't kill your mirror line. This I felt that I should have been able to delete, but for some reason it was being... Oh, because that's the edge of a UV island, that's why. Okay. Sorry, I just had a realization. So that makes sense to me now. But at the time I was like kind of irritated. So we'll delete a few more edge loops here, and then we're pretty much done. I mean, we're going to call that the game res mesh. The cinematic mesh comes in about 1200 triangles, I think, if I remember correctly. Yeah. And the game res mesh comes in about half that, around 600-ish. So yeah, we'll call that the game res mesh. So I've pulled the cinematic and the game res mesh back into Substance Painter and did the same process and threw the materials back on them. Now you can see that I was a little overzealous on the upper loop there because that crispness is gone from that edge. So that is something that I would normally go back and fix, but not for this demo. But you can see that otherwise they're more or less the same looking. And this is the last stage. I wanted to make a Sprite sheet that you can use for, say, your UI or whatever it's going to be. Well, your UI, or if you want to have a super low res version of the game, you can just lay a quad on the table with the key sprite on it. You know what I mean? But some stuff we'll see here is that it's you can get some super nice results actually by using the bake pipeline and doing all the normal stuff you would do with a standard mesh, except you're applying it to a sprite sheet. So the low poly in this case is just a quad, one big quad, and it's mapped 1-to-1 on the UV map, and all that's fine. I'm going to make a morph cage for it here, which is just basically scooting it forward until it's in front of all the high poly meshes. Snap that back. There's no need to mess with smoothing since it's one quad. And we'll go ahead and assign the low poly texture to it, and we'll bake out the normal map. Now you'll see this won't look 100% correct because it'll have edge bleeding on it, but you can see here this those are the keys that I want, and they're baking nicely. Good. And then the edge dilation kicks in. So we're going to save this out so we have it for later. Now the next stage we need to do is we need to bake out the alpha mask. And in Modo that means you have to switch gears and use the render output up top. I don't think there's a way to use the same pipeline as we did with the normal map. Yeah, it's a little weird, but once you get used to it, it's fine. So instead of baking to a texture, we're going to bake to the render output. And if I flip over there, you can see that we are rendering out the alpha mask for these keys. Now we're going to run into a problem here once this gets done, because I've left the edge dilation on. And what that means is it's going to put edge dilation on the alpha mask, and it's going to not be what I want, because I want that alpha mask to fit as tight as possible. And boom, there it is. And I'm like, damn it. So to fix that, we just have to go into the system preferences and go down to the bake settings, the final rendering, and set the UV border size to 0, and then rebake it again. And when this gets done, you'll see there's no edge dilation, and I can just save this out and go with it. Yeah, again, having to bake to a texture and then bake to a render output is kind of weird, but it's just sort of becomes second nature once you get used to Modo and its behaviors and idiosyncrasies. So anyway, there is a successful alpha map. So we're going to save this out and jump over to Substance Painter and see how to work with the sprite sheet there. So I've pulled the low poly mesh into Substance Painter, which is just a quad, like we said. I'm going to pull the normal map and the alpha mask in here so we can start to work with them. Now there's one extra step you have to do here when dealing with an alpha mask, and you'll see. So we drag the normal in like normal. And then I'm going to do the usual bake thing that I've done before. Now since we're dealing with a flat sheet, we're not going to get really... the ambient occlusion is going to be a little weak, but it's not going to matter that much, to be honest. That bakes away. Okay. So we have our curvature and all that baked out. So I'm going to do my standard technique where I do the overlay. And you can see this is already looking kind of cool. And this is applicable to a lot of different stuff. You can do lots of cool stuff, baking stuff to a sheet. It's surprising how good it looks, to be honest. So we'll throw the material on there, and there we have it. Now to mask these out in Substance Painter so I can see them correctly, we have to do a couple things. First, we have to change the shader from the standard PBR to the PBR with alpha testing. That's going to allow us to use a real-time opacity channel. But it doesn't show up yet because we have to add an opacity output. And then we have to put something into that opacity channel. So we turn off all the channels except the opacity, drag our alpha mask in there, and boom, there we go. Sprite sheet keys that are normal mapped and have nice curvatures and all that good stuff. And those, in my opinion, look friggin' fantastic. So that's that. Hopefully you were able to glean some information out of that was useful. And I'll see you next time.